Hello to everyone. Today practice is practice 2, measuring of fundamental electrical values. That means we are going to measure electrical current, electrical voltage and electrical resistance. First, we are going to some definitions of these values. We need to know what about we are talking about. And first is the question, what is electrical current? The electrical current is directed motion of electrons, charge carrier, from place where are more of them, it's minus polarity, to the place where are fewer of them, it's plus polarity. Because the electrons are negatively charged and the place there are most of them, they're going to the place where is the low of them. This is the schematic of technical direction of current and electrical direction. This is minus polarity to the plus is the real direction of current, and this is the technical direction of current from the plus to minus. Real direction of current from minus polarity to plus polarity. Technical direction of current from plus polarity to minus polarity. Mark of the electrical current is big letter A. I measuring unit for electrical current is ampere with a big A letter. An instrument used to measure current is ampermeter. The symbol of the ampermeter is in schematics, is like this one, and it's very important to know that ampermeter has a very low internal resistance, and it's connected in a series in electrical circuit because he must leave the most of current from him, because we needed current to measure. Other question, and the definition is, what is electrical voltage? Electrical voltage between two spots presents potential difference electrical states where these points are located. Electrical voltage is difference in two potentials. Mark of electrical voltage is U, and measuring unit for electrical voltage is big letter V, volt. An instrument used to measure voltage is voltmeter. This is some principle how to connect the voltmeter in the source. Voltmeter symbol is in schematics are on this, and voltmeter has an infinitely large internal resistance and is connected parallel in electrical circuit. That means that he's blocked the current to flow through him, and he must go the same polarity, plus to plus or minus to minus, to measure the differential potential, different potentials on that state. Definition is, what is electrical resistance? Electrical resistance is physical feature of particle material to resist the passage of electric current. A resistor is an electronic element, that is the between difference of the resistor and the resistance. Is made of particular material which contains the feature of resistance. This is the schematic of with a resistance and the circuit, which by the electric field electrons are going to flow through the wires and the material of which is made the resistor, and there is a crashing with atoms and molecules of the material, and that the material is resisting to flow the electric current. Mark for electrical resistance is big letter R. Measuring unit for electrical resistance is ohm. Ohmmeter symbol in schematics is like this, and an instrument used to measure resistance is ohm meter, which used for direct measurement of resistance, and UI method of indirect measurement by measuring voltage and the current on the resistor, and with Ohm's law, we are getting the real value of resistance. Something about digital universal instrument. He's used to measure different types of electrical values like inductivity, capacity, resistor, voltage or current, and it's more for use easier maybe than analog instrument, because we need to connect two connectors and in the circuits and the measuring scope, and we are going to have a measuring which is maybe in some cases precisely than with analog. This is the parts of the digital instrument. Power button on to turn off, on or off the instrument, screen, digital screen for reading measured values, common connector for measuring voltage, current or resistance, connector for measuring voltage and resistance, MA connector for measuring lower current values in milliamperes and microamperes, ampere connector for measuring higher nominal currents in amperes. This part is the switch for selecting functions: amperes, volts, ohms, direct current, alternating current, and same, and etc., and measurement ranges. Digital universal instrument connected as an ampermeter. In this practice, we are going to use digital universal instrument to measure the current in the circle. Like this, we must do schematic is like this, and we have a source, ampermeter, and resistance, and this is how we need to connect the circle. In the circle, we are measuring current through the resistor, which the voltage is 9 volts, resistance is 1 kilo ohm, Ohm's law, R divided by R, 9 divided by 1000 is 0.009 amperes, and that is current in 9 milliamperes. Why is that important? Because that we need to choose the connector for measuring a smaller current. We use the milliampere connector plus because we measure the current in milliamperes according to the calculation. This is the plus polarity. COM connector or port is used with every connections and measuring other values. It is minus polarity. According to the rule, we are going to choose the measuring range to be equal to or the first larger than the measured value. We've got to measure 9 milliamperes, and the first measuring range or measuring scope is 20 milliamperes. Like that on the switch. We have got the resistor. We have got his polarity. Red is the plus and black is the minus. Source is red the plus and black is the minus. And this is the circuit connection rules. It's 4 rules that we must respect to do the right connections of the circuit. First, we must serial connections. From other rule is from the consumption resistor to source, and third is from minus polarity to plus polarity because it's the real direction of the current, and on the end is the parallel, which we are going to connect the voltmeter. Sorry. Okay, first wire is minus of source to the minus of resistance. Second wire is from the plus resistor to minus of the instrument, and the plus instrument milliampere connector port to the plus of source. And that's the real circuit connection, and we are going to have a right measuring. On the other slide, we are going to say about the analog instrument or multimeter, because the multimeter, we are going to say now about words of analog instrument. The multimeter is same like the digital, but he has some other rules how to connect and how to choose the scale or measuring scope. like this. This is some type of the analog instrument. We have got some other connectors on the other side to upper. These are the connectors for measuring voltage, current, and resistance. And this is the scale and reading range for reading the measured values. We got different scales, and we must choose the right one to measure electrical value. This part is the switch for selecting functions which we are going to measure. Ampermeter, amperes, volts, ohms, direct, alternating, and such, and measurement ranges from the different measuring values. To read the measured value, we need to know the following concepts and quantities of the analog instrument. First is the scale, then show scope, SS, measuring scope, MS, instrument constant, K, deflection of the moving part of the instrument or pointer, alpha, and measured value X. So on the other slide we are going to see to say some words about that values we must. First is the scale. It consists of the graduation of the number labels. Graduation is formed by the dashes that allow you to accurately determine the position of the moving part of the instrument, as we see on the picture. The end number on the scale often serves to approximate the measured value. Scales can be linear or non-linear. Linear means that the difference between the two dashes are on the same range, they've got same value. Non-linear, that means that they are no same, and we can say they are logarithmic, quadratic, or hyperbolic. More precise scale are scales with a larger number of dashes because we can accurately determine the position of the moving part on the instrument of the pointer. That is the scale. Measuring scope is the second. MS in the entire length of scale on which the deflection of the movable part of the instrument can be read. That is the measuring scope. The indicative range is the total number of divisions, dashes, of the scale. In this picture we can see this scale, the final number is 50, but total number of divisions are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is important because we are going to measure or direct voltage, direct DC voltage or AC voltage. We need to choose the properly scale to read the value accurately. Third is the measuring scope. MS is the highest value of the measured quantity up to which the instrument can be measured. That means if we choose the 30 volts, we can measure the most of the 30 volts. If we choose 300 volts, we can measure with that instrument 300 volts. The measuring range is selected with a switch on the newer instruments or by connecting different connectors of the instrument. On this the older type of voltmeter, we use connectors and wire and select directly measuring scope. After we choose the measuring scope and the pointer scope instrument constant is the K is the next value. On the definition is value that indicates how many units of the measurement quantity correspond to one part of the scale. That means how much one line on the scale is worth volts, amperes, or such. Formula for calculate the constant is the MS divided with SS. Measuring scope divided with show scope, because this is the biggest value which we can measure with instrument, and divided with the number of dashes to find out how much one line on the scale it's worth volts, amperes, and such other measuring quantities. Number 5 is deflection of the moving part of instrument. It's a pointer, alpha. At which part of scale did the pointer stop during the measurement? This is the example. We've got 1, 2, 3 dashes, 4. It's between 3 or 4, and that is the 3.5 dashes on this scale. 6 is the measured value x. It is obtained by multiplying the constant by the deflection of the pointer. That means that x or any other value we are measuring, voltage U or current I, equals the alpha multiplied with K, constant. This is an example. A voltmeter with measuring range of 100 volts has a scale with 100 scale divisions. What voltage is measured if the pointer stops at the 35th part of the scale? The constant is ms divided with ss. 1000 divided with 100 is 10 volts, but parts of the scale. It's the value of the 1 dash. U equals alpha multiplying with K. 35 multiplied with 10, it's 350 volts is that result. Now we are going to see how to analog the universal instrument connect as a voltmeter, because in our practice we are going to use him like a voltmeter. This is a schematic. It's very simple. We measure voltage of 9 volts. This is the voltmeter, and this is the 9 volt source, plus and plus, minus and minus. According to the rule, we choose the measuring range to be equal to or the first larger than measured value. It's 9 volts is the source, and we must choose on the measuring range or a measuring scope 15 value of the 15 volts. This is the source, plus 9 volt, plus is red, black is minus. We need to choose common connector, which is minus, and connector volt to measure the volts, and connect parallel, minus and minus, plus and plus. This is the scale. We are measuring DC voltage, and so we have to look at the red DCV scale. We can calculate the constant. Here is the 60 parts of the scale on the DCV scale. ms divided with ss is 15 divided with 60. 1 part of the scale constant is 0.25 volts per scale. This is the pointer. Pointer shows the alpha is 36th part of scale, and we are going to calculate the voltage is K multiplying with alpha. 0.25 multiplied with 36 is 9 volt measured value. That is the example. This is the exercise task. The instrument in the picture for the practice has a measuring range of 500 volts. We are measuring an alternating voltage. This is important because we must choose the right scale on this instrument. What is the instrument constant? Is the A. B. What voltage is measured if the pointer has stopped as shown in the picture, and C. What is the deflection of the pointer if a voltage of 360 volts is measured. We use the two formulas. First is for constant. Measuring scope divided with show scope is 500. We must look this is the mark for the alternating current is the lower scale, the red one, 10, 20, 30, 40, 50 parts of the scale. 500 divided with 50, it's 10 volts per scale. How do we get the result of the voltage? U equals K puta K multiplied with alpha in equal 10 puta 47, 10 multiplied with 47, because it's 10, 20, 30, 40, 1, 2, 3, 4, 5, 6, 7. It's 47 part of the scale is the alpha, and it's 470 volts. The C, U equals K multiplied with alpha. Alpha in that formula equals voltage divided with K. 360 divided with 10 is 36 divisions. Now, measurement of the resistance using the UA method. This is important because we want to see how we must put the instruments in the circuit, because it's very important from the which we are going to measure the resistance with a big resistance or a smaller resistance uh, to have a smaller pogreška. Measurement of the resistance using the UA method, the second schematic. The source voltage U and the current through the consumer IT are measured. Now the voltmeter is in front of the ampermeter, and we have got these values. I is the total circuit current. EA is the total current of the circuit passing through the ampermeter. IV is the current passing through the voltmeter. IT, the current that passes through the consumer. And U equals UV. This is the voltage of the source. RT, the resistance of the consumer, which we calculate using the UV method. RA, internal resistance of the ampermeter. RV is the internal resistance of the voltmeter. Second Kirchhoff's law for voltage UT is that the second Kirchhoff's law said that adding the voltages in the circuit must be equal to the voltage of the source, and that UT is the U minus UA, and that means equal UV minus EA multiplied with RA. We calculate the resistance RT by the formula. RT is UT divided with IT for Ohm's law, and we can, with the large resistance, the voltage on ampermeter is much smaller than the voltage UT, so we can ignore the difference between UV and UT, and the resistance can be calculated by the formula. RT is the equal UV divided with EA. And this connection, the connection of a voltmeter in front of an ampermeter, can be used to measure high resistance of the consumption using an ampermeter with a little internal resistance as possible. In that part we can get the lower measuring mistake. And practice. We must do practice in our laboratory is the measurement of the electrical resistance using the UI method. You must connect the ampermeter and voltmeter according to the schematics, determine the constant of the instrument, measuring ranges, measure current strength I, source voltage U for all DC voltage sources on the table, 3 volt, 9 volt, 15 volt, 24 volt and 30 volts. The aim of this exercise is, based on the measured value of using Ohm's law, to calculate the resistance value of the resistor for each individual measurement from the both of schemes. First schematic, the ampermeter in front of voltmeter, and second schematic, voltmeter in front of the ampermeter, because we need to measure two times. For first schematic, we need to measure for the resistance which is small and for bigger, and we must connect the other schematic to connect the voltmeter in from the ampermeter, and for the smaller resistance and for the bigger resistance. And we must compare the results to see which schematic is better for which consumption. Graphically, we must display the UI curve direction of the resistor for each individual measurement. We are going to do with spreadsheet programs, MS Office Excel or LibreOffice, and to show the results to see how they look. This is it for this practice, and good luck. Thank you very much for your attention.